Okay, today we're going to look at the idea of limiting reagent, or sometimes it's also called limiting reactant. Okay, and it's kind of just this idea that something, a chemical, the limiting reactant is the chemical that will run out first in your chemical reaction. Okay, or the reactant or reagent that will run out first in your chemical reaction. Okay, so and we're familiar with this idea. Okay, let's say we're making some pancakes or something, and we need 2 cups of flour, and I'm going to put in 3 eggs. And we'll just pretend that's all you do for pancakes, and then you make a pancake. Okay, so now let's say I have 2 cups of flour in my pantry, and I have 6 eggs. Well, I can't use all of this to make pancakes because my flour is going to run out before my eggs run out, because my ratio is every 2 cups, I need 3 eggs. Well, in this case, I have enough eggs to make 2 pancakes, but I have enough flour to make 1 set of pancakes. Okay? Or say you're at a bicycle shop, and you're building bicycles, and some stuff you need for bicycle. Let's say you need 2 wheels per bike. Okay, so here's our nice little wheels, and plus 1 frame. So there's my bicycle frame. Very nice. Okay, so to make our bike, we need 2 wheels and 1 frame. Okay, and you're going back and you're putting frames together, and let's say we have 14 wheels in the shop, and we have 10 frames. Well, how many bikes can you build? Well, we look at our ratio here. Well, it's a 2-to-1 ratio, correct? I need 2 wheels per every 1 frame. So wheels, I have enough to make 7 bikes. And frames, I have enough to make 10 bikes. Well, does it matter that you have enough frames to make 10 bikes? No, because my wheels are going to run out. So in this case, the wheels would be my limiting reagent or limiting reactant. And how many bikes can I make? I can make 7 bikes. Your excess doesn't matter. All you need to know is, oh, that is an excess. The limiting reagent determines how much product or how much stuff you can make. Okay? So there's some non-chemistry examples. It's pretty easy. Let's take a look at a chemical reaction here and see how this works. All right. Let's say we have, let's say we're making sodium chloride from its elements. So we're synthesizing sodium chloride from sodium and chlorine. It goes together to make 2 moles of sodium chloride. All right. And let's say I have 5 moles of Na, and I have 2 moles of chlorine. Okay, so I have 5 moles of sodium and 2 moles of chlorine, and I want to know how many moles of NaCl can be created from this. So let's look at what we have. Well, we have our mole ratio. Okay, so what we're going to do is couple different ways to do this, but what I'm going to do here is I'm just going to convert to moles of the product. Okay, so how much I have 5 moles of sodium. Well, how much that could make? That can make 5 moles of NaCl. 1-to-1 mole ratio. I have 2 moles of chlorine. It's a 1-to-2 mole ratio, so for every 1 mole of this, I can make 2 moles of this. So if I have 2 moles, then I can make 4 moles of NaCl. And now we just compare. Well, I have enough sodium to make 5 moles. I have enough chlorine to make 4 moles. Well, this is going to run out. This is my limiting reagent. I cannot make 5 moles because after I've made 4 moles of sodium, I have no more chlorine. So what would my answer be? It'd be 4 moles of NaCl. Let's do another example problem here. Let's say we've got this reaction. So we have sodium chloride. Sorry, that's sodium chloride plus silver nitrate goes to silver chloride plus sodium nitrate. And let's do it with grams this time. How many grams of silver chloride can be produced from 100 grams of NaCl and 100 grams of silver nitrate? Okay, so here's our problem. Now, I'm in grams. That's not as helpful because what's the only way you can compare chemicals is through moles. So the first thing I'm going to need to do is I need to convert these two values for mole. Okay, so I've got 100 grams of sodium chloride, so I'm going to convert, I know 1 mole is 58 grams. And let me get a calculator real quick. So I'm going to convert to moles of sodium chloride. And I find out I have 1.72 moles of NaCl. Labeling is going to be really big when we're starting to do more complex problems, so make sure you're labeling. Okay? So then I'm going to do the same thing over here. I have 100 grams of silver nitrate, and I'm going to go ahead and convert. I know that 1 mole is 169 grams. And I only have 0.59 moles of AgNO3. Okay, so now that I'm in moles, I can compare. Even though I had 100 grams of both of these chemicals, I have very differing mole amounts, right? I have more than 3 times as many moles of sodium chloride as I do moles of silver nitrate. Okay, so now we go, look, my mole ratio is a 1-to-1 mole ratio. Okay, actually it's 1-to-1 all the way across. So from sodium chloride, I could produce 1.72 moles of AgCl, and silver nitrate, I can only produce 0.59 moles of AgCl. Well, what produces least moles? This is. So my silver nitrate is my limiting reactant, and it determines how much product I can make. So let's finish this off. So this is the value I'm going to use now. I can't actually make this because the silver nitrate will run out first. So then to finish off, to find how many grams, now I have 0.59 moles silver chloride. I'm going to multiply that by its molar mass, which is 142 grams per 1 mole. My moles cancel, and I'm left with 83.78 grams. Okay, so recap real quick. Your limiting reagent is your chemical that runs out first, okay? That runs out first or can produce the least amount of products. So again, in this example, even though I had enough sodium chloride to produce 1.7 moles of silver chloride, I only had enough silver nitrate to produce 0.59 moles of silver chloride. So silver nitrate would have been my limiting reagent. Okay? You've got to compare them through moles, right? And then your limiting reagent determines how much product you can make.